Okay, good morning everyone. Today we are doing section 3.3, which involves rational exponents. So remember, a rational exponent would mean a exponent with a numerator and a denominator. So we're going to start off with introductory question. What size beach ball is required to keep you afloat? All right, so to start off, we would write the formula for volume of a beach ball. So volume of a ball is equal to 4/3 pi r cubed. Okay, so now to figure out the size of a beach ball to keep you afloat, essentially what you do is you figure out how much water the beach ball will hold, and the weight of that water has to equal your body weight. Okay, so suppose that you weigh, let's say, 50 kilograms, okay, which is equal to 50,000 grams, which is equal to 50,000 centimeters cubed. All right, so all you do is you just plug that in for volume into your formula. So we have 50,000, and we're going to look to solve for radius, is equal to 4/3 pi r cubed. Okay, so now we're just going to rearrange. So we're going to have 50,000 times 3 divided by 4 pi is equal to r cubed. Okay, so we would evaluate that. I'm not concerned with what the answer is right now. Okay, now in order to get rid of the 3, what we have to do is we have to do something to both sides of the equation, right? So remember from our exponent rules, if we put the exponent 1/3 outside like that, right, you multiply exponents, and 3 times 1/3 is just equal to 1. So you'd have r by itself. So then you'd do the same thing to the other side, 1/3, and that's actually called the cubed root. Okay, so you can finish that off on your own. Okay, so this is a rational exponent. All right, so it says rational exponents that have a numerator and a denominator. Use your calculator, determine the following. So to plug this into your calculator, you would do 4, hit your exponent button, bracket, 1 divided by 2, close bracket, and the calculator will give you 2. Okay, right here, the calculator will give you 5. And right here, the calculator will give you 4. All right. So 5, again, is the cube root of 125 because 5 times 5 times 5 is equal to 125. Okay, we'll talk about this one in a minute. Okay, so to generalize, a to the 1 over n is the same thing as the nth root of a. Okay, which means I'll say the nth root of a. Okay, and this is a number, I should put a semicolon, a number that multiplies itself n times to equal a. All right. Now, when we have a numerator other than 1, so I have an m, a to the m over n, okay, this is the same thing as saying a to the 1 over n to the m outside, okay, or similarly, a to the m to the 1 over n. So it's just a two-step process, right? So I just wrote it in radical form. Okay, this is called radical form here. So we can do a to the m first and then do the nth root like this. Or we can do the nth root of a first and then apply the exponent m. Okay, so let's go back to our example here. Okay, what we did here, the easier way I find is to do the denominator first. So we're going to do the cube root of 8 first, and then square the answer. So this is a number that multiplies itself 3 times, give you 8, which is 2, and then we square it, which is equal to 4. Okay, good. Okay, so I said evaluate without using a calculator. Okay, so again, I'd like to do the denominator first, and then write it like that. Okay, and then 25 to the 1/2. Okay, remember 1/2 is same as the square root. Okay, because the number 2 tells you the roots. The square root of 25, which is 5. So we have 5 cubed, which is 5 times 5 times 5, 125. Okay, next one. Okay, again, you're going to apply the 1/5 first, and then square the answer. Okay, and the 5th root of 32 is 2. So we have 2, and then we're going to square that, which is equal to 4. Okay, now when we have a fraction, okay, we're just going to break it up, and we're going to apply the exponent to the numerator and to the denominator. So we have 9 to the 3 over 2 divided by 25 to the 3 over 2. Okay, I'm just going to write it this way here. So we have the square root of 9. Okay, I'm not going to write all the steps here. So we have the square root of 9, and then we're going to cube it. So square root of 9 is 3, so we're going to get 3 cubed. Square root of 25 is 5, so we have 5 cubed. And we get 27 over 125. So any question I ask like this, the bases will usually be like 2, 3, 4, 5. You won't get much higher than that. Okay, so this example here has us write these in radical form. So right now these are called in exponent form or exponential form. So we're going to write them in radical form. Okay, so this one right here in radical form, write the 16, and then the root goes right here. Okay, that's it. I didn't ask you to evaluate. We don't care what the answer is. This one right here, the 3 goes out front, and we can have the 8. And now the square can go here, or it can go on the outside. Okay, and this one right here, because we have a negative exponent, we're going to write it so it's 1 over the square root of 16. Okay, notice that I didn't write a 2 there because 2 is the default. Okay, so the square root of 16 is the same thing as the, okay, again, it's the default. All right, so now we're going to apply this with what we sort of did yesterday. Okay, so first one, we're multiplying in the numerator and then we're dividing. So when we multiply like bases, we add the exponents. We'll do this in 2 steps. So we're going to add these exponents. So we're going to get x to the, so we have 1/5 plus negative 3/5 is negative 2/5 divided by x, or x to the 1. So that's equal to x to the negative 2/5 minus 1. Okay, we do common denominator, so that becomes 5, so it becomes x to the negative 7/5, and that's equal to 1 over x to the 7/5. Okay, next one. Okay, again, we'll do it in steps. So when we have a power of a power, we multiply, so we're going to get 6 times 1 over 3. So, right, 6 times 1 over 3 is just equal to 6 over 3, which is 2. So we have x squared, and then we're going to times that by x to the negative 8 times a half, which is negative 4, which becomes, add the exponents. So we have x to the 2 plus negative 4 is negative 2, which is 1 over x squared. Okay, done. All right, and the last example here. Okay, so this is a tough one because we have like a negative fraction and a rational inside. So we're just going to apply this negative to each of the 4 things inside. So we have 25 to the negative 3 over 2, x to the, again, we multiply, so we're going to get 2 times negative 3 over 2, which is negative 6 over 2, which is negative 3, over 36 to the negative 3 over 2, and then y to the negative 1 times negative 3 over 2 is just 3 over 2. Okay, now we're going to flip some stuff because we don't want negative powers. So both terms in the numerator are going to go to the denominator, and only one is going to go to the numerator. So we're going to have 36 to the 3 over 2 over 25 to the 3 over 2, x to the 3, y to the 3 over 2. Okay, we're almost done. Now we just want to evaluate the two numbers. Okay, so we are going to get 36 to the 3 over 2, so that's the square root of 36, which is 6, and then cubed. I'll just do an extra step here. Square root of 25 is 5. We have 5 cubed, and then the x cubed stays, and the y stays as 3 over 2. And we get 216 over 125 x cubed, y to the 3 over 2. And that's it for today.